Hey, everybody. So, hopefully, you're watching this on Monday. You've just taken the Gateway quiz and done spectacularly. Everybody passed the first time, hopefully. And so now you are looking for the lesson of the day. And I'm looking at myself. I'm realizing I always wear hoodies and sweatshirts on the weekends when I make these videos, and then I dress up during the week. But it doesn't really matter, I guess. Um, So today's lesson is going to be just kind of me doing a few examples using derivatives that we've learned in a couple different contexts. And then moving forward from here, it'll be a similar lesson on Wednesday. We'll be synchronous again on Wednesday, and I'll be going through different kinds of logs, different types of exponentials. We'll learn some new rules, but we are headed relatively quickly toward the end of this chapter. So just keep in mind that the next common exam is going to be not this coming Thursday, but the Thursday after that. So Thursday, December 10th is our next common exam. Hopefully by the end of this week, I've got a review assignment ready for you guys, and we'll make sure that we'll be able to do really well on that common exam. But without further ado, I am going to go through a few questions. All right, here we go. First example, first type of problem that I would like to take a look at is one where it just says find an equation of a tangent line. So something that we've certainly done before, but in the context of a natural log equation. Of course, we need to know what is the value of the function at that place and what is the value of the derivative at that value of x. And so those are the two things that we need. We can, of course, find the value when x equals 2 by plugging it in. And if I plug in x equals 2 here, we'll have 2 cubed 8 minus 4 minus 3. 8 minus 4 minus 3 is 1. Natural log of 1. Conveniently, I don't need a calculator for natural log of 1. Log base anything of 1 is equal to 0. And then to find y prime, of course, we will need to find y prime generally as a function of x. So the derivative of the natural log of something is 1 over the something. I'm not going to write the 1 down because we also have chain rule happening here, and so we'll have to multiply by the derivative of the something. And so the derivative of the something, 3x squared minus 2, I'll just put that in the numerator. So instead of having two different things that I'm multiplying, I'll just have one fraction. So y prime of 2 is, let's see, we'll have 3 times 2 squared, 12 minus 2 is 10. And we already found that 2 plugged in here gives us 8 minus 4 minus 3, which is 1. So the value of my function at that point is 0. The value of the derivative at that point is 10. And that's all we need to come up with the equation for a tangent line. Y minus the y value equals the slope at that point, the value of the derivative at that point, times x minus the x value. And I really honestly have zero problem with you leaving the answer in that form. If you want to switch it into y equals mx plus b, that's okay with me. But why not keep it here? I can look at this and say the slope is 10, and a point that it goes through is 2, 0. So there we go. Find an equation of a tangent line. One type of problem. Another type of problem is you're going to be doing some higher derivatives. I think in your assignment, I'm looking at the book right now. I think you only go to the second derivative, but this is kind of a fun one for us to take a look at multiple derivatives. So I'm going to go ahead and do that. My function is x cubed times natural log of 3x. And so product rule, I've got this thing times that thing. So my derivative is derivative of the first times the second plus the first times the derivative of the second. Now, the derivative of 3x, I suppose it's 1 over 3x times 3, but we saw on Thursday that the derivative of the natural log of x, the derivative of the natural log of 3x, the derivative of the natural log of 10x, it always turns out to be 1 over x. in this case 3 over 3x, which simplifies to 1 over x. And the big reason that I wanted to go through a problem like this is to, I guess, emphasize the importance of simplification. I know on your gateway quiz that you all just passed, you didn't have to simplify, but if I'm doing higher and higher and higher derivatives, I probably want to simplify something like this. And in this case, x cubed over x, whoops, should be a plus sign, is x squared. And this saves me trying to do some product rule or quotient rule or something more complicated than what I need to do. And we'll see as we move along, this one will get even more and more beneficial for us to simplify. Moving along, the second derivative, I will now do, again, product rule here. I've got the derivative of 3x squared times natural log of 3x plus 3x. Whoops, sorry about that. The derivative of 3x squared is just 6x. So that's 6x to the first times 3x. And then 3x squared times the derivative of the natural log of 3x. We already said that was 1 over x. Plus the derivative of x squared, or 2x. And then once again, it behooves us to simplify a little bit. Not too much simplification here. But I can say that 3x squared times 1 over x, one of those x's is going to cancel out, and all we're going to have left is 3x. And look at that, 3x plus 2x is 5x. And it's not difficult simplification, but any simplification I can do is going to help me with my third and fourth derivatives as we move forward. Okay, 2 down, 2 to go. My third derivative, here we go again. I've got a product. I've got a function of x times a function of x. So my derivative is the derivative of 6x times the natural log of 3x times, plus 6x times the derivative of the natural log of 3x. For the third time in this problem, it is 1 over x, plus the derivative of 5x is just 5. Well, look at this. X times 1 over x cancels out. All I really have here is 6 plus 5. That's just 11. 6 times the natural log of 3 plus 11. And this is a rare case where as we differentiate, the problem or the expression is getting simpler and simpler instead of more and more and more complicated. But that's okay. We'll take it. The derivative of 6. Now, this is no longer a function of x, so I don't need to use the product rule. This is just 6. And so the derivative of 6, oh gosh, I missed the x there. The derivative of 6 times the natural log of 3x is 6 times the derivative of the natural log of 3x. If you do product rule, you're not wrong. You're just making this problem more difficult than it needs to be, because the derivative of 6 would be 0. So half of the product rule just ends up going away anyway. And then the derivative of 11 is 0. So that's it. There is my derivative, my fourth derivative of x cubed times the natural log of 3x. Kind of an unusual problem where it actually simplifies as we go. Not always going to happen, but it is definitely beneficial to you for the problems in your homework that you're going to be working on for Wednesday. Simplify your derivative, because then when you take the second derivative, you'll have easier work to do. All right, moving along. I've got a couple of weird cases here. Some chain rule. And when you do your homework, you'll see why I'm doing problems like this one. Basically, this one's just an exercise in keeping straight. And I'll make sure you guys can see what's happening here. I've got e to the e to the e to the x, which I'm not going to find a real-world application for this one. But all I'm looking for here is the derivative. What is the derivative of e to the e to the e to the x? Well, the derivative of e to the whatever is e to the whatever. So the derivative of e to the, this is my stuff inside at this point. The derivative of e to that stuff is e to that stuff times the derivative of that stuff. Well, the derivative of e to the x, the derivative of e to the x is e to the x. But now my stuff inside is e to the x. And so the derivative of e to the x is e to the x times e to the x. And that's it, because now the stuff inside is just x, and the derivative of x would just be 1, so I won't write that down. And then a analogous situation with the natural log is the natural log of the natural log of x. And if I want to take the derivative of something like this, well, the derivative of the natural log of something is 1 over the something times the derivative of the something. Our something in this case is the natural log of x, and the derivative of the natural log of x is 1 over x. But I've got a fraction inside of a fraction. Let's call this 1 over x times, let's see, the reciprocal of the natural log of x over 1 would be 1 over the natural log of x, or we could think of this as just 1 over x times the natural log of x. Composition of functions. Ain't it a wonderful thing? Whoops, typo here. This is what I get for doing stuff at 11 o'clock at night. The derivative is 1 over the natural log of x times the derivative of the natural log of x, which is 1 over x. And then simplification that follows. All right, and then one last one for me to go through with you, and looks like our time, we're doing all right, is a question where it says, here's some function, and you got a few of these to look at in your homework tonight or tomorrow night, whenever you do your homework that is due on Wednesday, but some function involving a natural log. And I want to find, that looks like an exclamation mark. That's not what it is. I'm finding y prime, comma, and stating the domain of y. And this is just something we haven't talked a lot about. But when we talk about domain, we need to just make sure that when we take the square root, we're doing something greater than or equal to 0. If I'm doing a fraction, doesn't really matter what the numerator is, but I just have to make sure that the bottom is not 0. And then finally, if we're doing a log, and that's what comes into play for the problem that we're doing right now. When we do a log, we just have to make sure that the something inside of here is greater than 0. So square root has to be positive or 0, can't divide by 0. And when we do the log of something, we have to make sure that we are not doing the log of a negative number. All right, so first things first, well, maybe not. Since I'm talking about the domain, let's maybe talk about that. As far as the domain of this one goes, I just have to make sure, let's see, I'm squaring something, so it will certainly not ever be negative, so no worries there. I just have to make sure that sine squared is never equal to 0, which means I have to make sure that sine is not equal to 0. So the sine of x cannot be equal to 0. And then I just have to think, maybe you're looking at the unit circle, maybe you're looking at a sine curve, and just thinking about what a sine curve does. But either way, we're going to think about places where the sine is equal to 0 would be 0, and then pi, and then 2 pi, and then 3 pi, and then 4 pi. Or maybe if you're looking at it this way, you're saying it crosses at 0, and pi, and 2 pi, and 3 pi, etc. And so my domain, if I'm going to state my domain, I would probably state it something like this. X cannot be equal to pi n, where n is an integer. And an integer can be positive or negative, so this includes negative 3 pi, negative 10 pi, or any value where we are on the horizontal, either to the left or to the right of 0, or above or below the axis. We're looking at all those places where it's not equal to 0. So that's my domain. And it's different problem to problem. Sometimes you're worried about dividing by 0. Sometimes you're worried about radicals. And then the rest of this one is actually just another derivative. Let's go ahead and take the derivative y prime. Well, here we go again. I've got the natural log of something. So the derivative of the natural log of something is 1 over the something times the derivative of the something. And maybe I'll do this. I'll put the prime there. So here's my general form. I've got the derivative of natural log of sine squared is 1 over sine squared times the derivative of sine squared. And maybe that helps you. I'm noticing on some homework, on some of your quizzes, that our notation is getting a little bit sloppy. Some people are using the derivative phrase a little bit loosely, but we can talk about that a little bit a different day. The derivative of sine squared. Well, the derivative of something squared is 2 times the something times the derivative of the something, and the derivative of sine is cosine. And then look at that. One of those signs can cancel out. And so we have 2 times cosine over sine, and that is 2 times tangent. And so the derivative of the natural log of sine squared is 2 times tangent squared. And I already addressed the issue of the domain, so that is all I want to do with that problem. And I believe I'm going to peek. Yep, that's the only other problem I wanted to do as part of this lesson. So take a look at the homework. Just get some practice with these derivatives. Certainly, if there are questions, you can let me know about it. But yeah, that's it. Have a great day. I will see you all on Wednesday.